Bismillahirrahmanirrahim. Dear students, today the topic which we are going to continue is about the transmission lines. In the last lecture, we have come to know that how we can draw the fundamental model of a transmission line for per unit length. Okay, how it seems like? It just seems like this model in which R and L both of these components are connected in series, while C capacitance and G, that is conductance, both are connected in shunt, right. This model of transmission line is actually for per unit length, and such networks can be cascaded to form a distributed model. What is meant by cascaded? Cascaded means that that output of the first one or the output of the second one is plugged into the input of the second one or input of the third one, depending that which one you are going to plug. Then such type of connection is known as a cascaded connection, right. This model is also known as per unit model of a transmission line, right. So here we will discuss about the distributed networks and lumped networks, right. What is the fundamental difference between the distributed network model as well as a lumped network model? In a distributed network model, as you can see that we have multiple resistances that is going up to 11 meter, right. That is up to 11 meter we have such resistances, whereas for per meter the resistance in this particular network exists at 6 ohm, right. Therefore, if we want to find out the total resistance across this distributed network of 11 meter, how much resistance we will find? We will definitely find 11 cross 6, it will be 66 ohms for 11 meter long distributed network or 11 meter long transmission line, right. This will be 66 ohm, as we have 6 ohm resistance offered for each meter, right. Therefore, likewise, when we will convert this into a lumped model, what is meant by a lumped model? That we want to gather, we want to collect, we want to concentrate the whole network into a by representing a small resistance, right. Therefore, we have lumped this model, and this lumped model is equal to 66 ohm, right. So these are the two methods which are which are most frequently used for representing the networks, right. One is the distributed model and the other one is the lumped network model, right. I hope that you are clear in your stance that how we can describe or how we can define a distributed network as well as a lumped network, right. So after this concept, let's move on to the next slide, where I have to tell you that why we ignore G, right. Power is mostly measured in megawatt, while losses are always measured in few watts, right. And as you know that the term megawatt, it means that 10 raised to power 6 watts, right. The term megawatt is very much greater as compared to a few watts. That's why we usually ignore the value of G, and so the model of the transmission line becomes just like this, where we have resistance and inductance in series, whereas capacitance or a capacitor is offered in the shunt connection, whereas this model exists for a per unit length of a transmission line. Therefore, this per unit length is represented by this L, as shown by and below the figure, as shown below the figure, right. G is considered in communication systems. Actually, uh, this conductance part is considered in the communication system. Why we use why we consider it into the communication? Because we have to work on a very low voltage or very low current in order to turn off the communication devices or to turn off those devices. Therefore, in order to turn on and turn off these devices, we require very few millivolts or very few current. So with the very reduced amount of power, we can deal with the communication systems. That's why we cannot ignore this factor of G in the communication systems. However, it can be ignored into the electrical power systems. Why it can be ignored? Because the losses are in few watts and the power is measured in megawatts, right? So we have to ignore it. Moreover, I have told you in the previous lecture that the dirt factor can be considered, right, as well as the humidity and temperature factors can be considered, and they can also there is not any appropriate method that has been introduced till yet in order to calculate the different calculations, right? So therefore we mostly ignore G while considering the power systems, right? Now in the next step, let me show you that R and L, both of them are joined to form an impedance, right? Resistance and reactance both are summed up in order to represent them with the help of an impedance, which I have showed here in the Z series, right? Likewise, there is an other component across the parallel connection, which is capacitor. So we have replaced this capacitor with the Z shunt here. Z shunt can be capacitance can be represented by which thing? It can be represented by X is equal to 1 over j omega c or 1 over 2 pi f c, right? As you know that transmission lines has two branches in which the Z series is occurring for the R and L, whereas for the shunt connection we often use capacitance, but we may consider for the value of G, because for calculating the value of G there is no appropriate method, so we mostly ignore it. But in the case of long transmission lines, we can consider this value of G as it has somehow an effect over the output of those transmission lines. Therefore, we often consider G in the long transmission lines. If such structures are connected, basically this structure is for the single per unit length, right? And if such structures are cascaded, then they will form a ladder like structure. How ladder like structure? It will be just like this. These are the two side skirts and these are the middle skirts uh, of a ladder, right? So uh, basically this is a ladder type structure which is placed horizontally, and for this purpose here is the per unit length from the start to the first Z shunt. This is known as the per unit length, while the overall length of this transmission line is represented by L, right? Here in this case I have I have cascaded three sections of per unit length transmission line, and they formed a ladder like structure. If a slight modification is done in it, right, what is the slight modification I am going to do? That I am placing all the series impedances together and all the shunt impedances that are lumped in the end, then this structure will become just like this as I have shown here. In this case, the Z series, three components of the Z series are placed together, whereas these Z shunt, three components of Z shunt, these are lumped into the ending part of this network, right? So after it we can say that now we have to find the equations for Z series and Z shunt, right. For finding the Z series equations, what we will do is to uh, simply multiply simply add R and the resistance and the reactance, right. So, in order to add the resistance, we know that the resistance value is represented by R, whereas the reactance value across an inductor is represented by j omega L. So, I have placed these values and I have found R plus j omega L, right, as I have written inside the bracket here. And the total length of this transmission line is considered to be the three networks that are cascaded together. So, the overall length will be L, and we will multiply the single network impedance with the length L, and in the result we will find out all the values across Z series, right. As you know, here in this case that R is multiplied by L, this is RL, whereas I have written here JL, this is J, and from this we have placed the value of L, whereas I have taken the value of omega equal to 2 pi f, and when it is multiplied by L we have 2 pi FL inside the bracket, which is going to have the product with the JL, and then the overall term will be summed up with the RL, right. Correspondingly, we have to calculate the value across the Z shunt, and in order to calculate this value across the Z shunt, we know that all the connections that are in parallel, they will be deal like Z shunt is equal to 1 over j omega c into L, right. As you know that the capacitance across each inductance is represented by the reactance across each capacitor is represented by 1 over j omega c, right, and total reactance, how much we have the total reactance, it is it will be depending on to the length of the transmission line. Therefore, we have multiplied this j omega c with L, and we have found 1 over j c into 2 pi f L, right. Now, this term basically, as we know that admittance is the reciprocal of shunt of impedance, and in the shunt connections we often consider admittance instead of impedance. Therefore, we will place the value here, and as we also know that y is equal to 1 over z. So, we have placed these values here, and I have found this value equal to j c into 2 pi f L. Okay. So, we will calculate it in this manner, in these manners. Now, coming on to the next point, we can say that in both these terms we have FL as the common term, right. Here we have FL, and here we have FL, here we have 2 pi, and here we have 2 pi, but the factor of FL is considered on a major level. So, therefore, we can watch that both the Z series as well as the admittance, shunt admittance, these are the functions of FL, right. So, by the product of F and L, the frequency and length of the transmission line, it will affect the impedance in series and admittance in shunt connection, and also we know that Z series is not equal to Y shunt, right. Both series impedance and shunt impedance are dependent on frequency and length of a transmission line. Okay. So, now we can say that the frequency and length have direct effect on impedance of a transmission line, right. The frequency and length both have direct effect on the transmission line. How they have the direct effect, we will just calculate it, right. Now, just consider the first case in which the frequency and length have direct effect, so it means that Z series is directly proportional to FL, while Z shunt is inversely proportional to FL, right. How we have derived this expression? We have driven these expressions from this, right. This Z series is directly proportional to FL, right, Z series and FL, while if we watch this connection Z shunt and FL, these are inversely proportional, right, whereas Y shunt is directly proportional to FL. Therefore, we will consider this value and Z shunt will be inversely proportional to FL, and if I can further write in the form of admittance, then I can say that shunt admittance is directly proportional to FL, right. Therefore, low value of FL leads to low value across shunt impedance, right. Here, what is the meaning of this? That low value, if the value of FL is low, right, then the shunt impedance value will also be lower, right, and therefore, the less value of shunt impedance will be ignored, right. How much, as in the case of short transmission lines, we have less value of FL, right. Therefore, I will just explain this point, that how we have, why we have less value of FL, and how it can be dealt with. For the time being, let me tell you that low value of FL leads to low value across shunt impedance, and in case of short transmission lines, the value of shunt resistance is very low, right. Therefore, we often ignore this value of capacitance or this value of C in the short transmission lines, right. So, if we ignore this value of capacitance across a short transmission line, then we can also say that this value can be uh, uh, suppressed or neglected, and only we have the series impedance that is left inside the transmission line, right. Now, according to the international standards or internationally accepted value, we mostly know that the value of FL in case of short transmission line is up to 4000 hertz kilometer, right. The value of FL across the short transmission line is equal to 4000 hertz kilometer, right. So, if we have this value of 4000 hertz kilometer, then it is called as short transmission line, right. So, and therefore, we have to place this value, and here in Pakistan we know that the frequency is 50 hertz. So, therefore, we can take this 4000, right, FL. If instead of FL we will place the value equal to 4000, and on the other hand we have operational frequency of Pakistan, that is 50 hertz. So, if we divide 4000 hertz kilometer by 50, we can find out the value of resistance, right, sorry, not resistance, but the length of the transmission line. So, this length of the transmission line will become equal to how much? It will be equal to 80 kilometer, right. So, it is known to you that the value of short transmission line across Pakistan is 80 kilometer, or a transmission line that has overall length of 80 kilometer is considered as a short transmission line. Now, what things we have learned till now for the short transmission line, that the short transmission line has FL value of 4000, the operational frequency of Pakistan is 50 hertz, and the short transmission line is having the length of 80 kilometer, right. As well as we have also find out that in a short transmission line the capacitance factor is ignored, and after ignoring the capacitance factor we can find out the value that is equal to series impedance. In series impedance we have the series connection of a resistance with a reactance, right. Therefore, we can find out the next value. In the next value we can have the product of F and L for the medium transmission line, and in case of medium transmission line this value is equal to 12,000. So by 12,000 divided by 50 we can find out the length of the medium transmission line in Pakistan, right? As the value escalated for FL, therefore now the shunt capacitance cannot be ignored, right? Because the value is escalated for F and L. I have told you previously that whenever the value of FL will be low, we will ignore capacitance, right? As the value will escalate, as the value will increase, we cannot be able to ignore the shunt capacitance. Therefore, the effect of shunt capacitance will definitely be considered in case of medium transmission line, right? So we will discuss this phenomena of medium transmission line with the 4 different parameters, in which there will be the load condenser method, source condenser method, then nominal T method and nominal pi methods. We will discuss them in detail into the upcoming lectures, and also we can also say that the effect of this shunt capacitance will also be considered in case of long transmission lines, and also the effect of conductance will be considered in the long transmission lines when we will study them. Okay, so in the next lecture we will be able to try to find out the values of two port networks and in comparison with the transmission lines, and after finding these values of transmission lines we can find out the different we can have the lecture over the short transmission line and then over the medium transmission line by the 4 methods. Okay, so up till now this thing is enough, that now you have find out that why we cannot use the capacitance across the transmission line, short transmission line, and why we consider the effect of capacitance in a medium transmission line and long transmission lines, right? And also there are several other things that you have learned in this lecture. So this is all for today. Thank you very much for listening this lecture.